This project says that our friend is going to be going bungee jumping for her birthday. She wants to jump off a bridge, and she wants to touch the water right below when she gets to the bottom of the bungee cord extension. You want to double check all the physics to make sure this goes safe. Identify a few things you know about the bungee jump, and making reasonable assumptions for this property of the systems. Determine what would be true. So this is my little picture of my person going down. There's obviously going to be the cord involved, but we know we have weight. We know we have like air resistance up, but we know that the object is going to be going down with gravity. We know our distance starts. We can make 0 right above the water, and at the top we can make that our y final. We can make that our y final, which we could set it up the other way too. Anyway, we can make that our y final. The 0 we can make our y final. Our initial is going to be the mg. I know that at the top they're going to have 0 kinetic energy and then max potential energy, and at the bottom they're going to have 0 for that second that they stop before they go back up. They're going to have 0 kinetic energy, and then gravitational potential energy max as well. So I stated a few things that I know here just to kind of help me out think about this problem. So the object is going in the same direction as gravity, so I know that gravity is going to be positive because it's going down with gravity. The spring force is going to be negative work on the spring force is going to do negative work on the jumper because the jumper is going down and then the cord is pulling up. We know that we have to use gravitational potential energy. Energy gets exchanged back and forth during the jump. I don't know if I have to think about that or not, but that's just some of the things I stated. And then air resistance works against the bungee jumper, but I don't think we're going to include air resistance into this problem. So the things that I want to know is definitely the weight of the person. I need to know the elasticity of the rope. I need to know the distance from the bridge right above the water. I will think I need to know the height of the person so I can figure out how long to make the cord. So, what then? We would have to use in this case gravitational potential energy and potential energy of a spring, I would say. So the work is going to equal the change in potential energy, but it's going to be I initial minus final. The only thing is that we know the final is 0, so all we're going to do is start with their initial. If we had those to apply, that's to find the work done by our cord. Then here we would do on the person to find that we would use, now this is our potential energy of a spring, then here we would use for the person the gravitational potential energy near Earth's surface. So that would be technically it would equal the change in potential energy minus U initial minus U final, but that would equal work, which would also equal mgy. We know the final is 0, so we could just deal with the mgy, and we know it's supposed to be positive because it's working down with gravity. So once we have that, we would be able to find the total work, but just adding all the works together. So just having the sum of the work, which would be of the cord and person. So I think that would be the best way to determine what we need and what would be safe with the cord, how much work would be done on each other for this question.